Hello students. In this video, we are going to discuss about the quadratic equation when both the roots are less than a quantity k. If both the roots are less than a quantity k, then what will happen? So in this case, let this equation is ax square plus bx plus c equals to 0, whose roots are alpha comma. So first case, if a is greater than 0, then quadratic equation will represent this one. Let this is x-axis and this root is alpha and this root is beta. Suppose a quantity k is here. So we can see that this is fk. This length is fk. Because both the roots are less than quantity k. So first of all, since it is less than the quantity, so alpha beta must be a real number. Second, k, if I put fk, that should be greater than 0. And in third case, what we are doing that k should be here itself. Otherwise, if k is this side, then also fk would have been greater than 0. So just to ensure that k is on this side, so we are taking the average of the roots alpha plus beta by 2 should be less than k. But in this case, second case, if a is less than 0, then equation of quadratic equation will look like this. It will be downward parabola alpha, and let this point is k. So in that case, we can see that this is fk. So of course, d should be greater than equal to 0. And second, fk here is less than 0. And third one, alpha plus beta by 2 should be less than k. Why? Because just to ensure that k is this side, not this side. Because if k is this side, it would have been also the same condition. So just to separate that, no, k is this side after both the roots, we have introduced this condition. Now we can see that in both the cases, d is same, third one is same, but second one is different. So since it is a positive quantity and it is a positive quantity, so we can say that AFK will be greater than 0, and this is negative quantity and this is negative quantity. So in that case, A into Fk will be greater than 0. So if we write A into Fk is greater than 0, so both the cases are covered. We need not to discuss about A greater than 0 and A less than 0 separately. So overall condition in this case is simply 3. D is greater than equal to 0. A into Fk is greater than 0, and third condition is alpha plus beta by 2 should be less than k. So these are the three conditions through which we can restrict that both the roots are less than quantity k. Now we'll have an example over it so that you can understand the whole concept very clearly. The question is, find n for which both the roots of equation x square minus mx plus 1 equals to 0 are less than unity. Unity means 1. Then how to solve this question? So in this case, what we are going to do is, first of all, we are writing x square minus mx plus 1 equals to 0. So you can see that alpha plus beta is minus b by a and alpha beta is c by a. Our first condition is D should be greater than or equal to 0. Second, A into Fk should be greater than 0. And third is alpha plus beta by 2 should be less than K. So first condition we are going to use when D is greater than or equal to 0. D means here A is 1, B is minus M, and C is equal to 1. So it is a B square minus 4AC should be greater than or equal to 0. So B square means M square minus 4A and C. So we can see that it is M plus 2, M minus 2 greater than or equal to 0. So M is from minus infinite to minus 2 union 2 to infinity. So this is the first condition which you have to write down. Now second condition A means here it is 1. Fk, K is again 1 because it is given unity. K given is 1. So AF1 should be greater than 0. F1 means we are taking Fx as the quadratic equation. X square minus mx plus. So it is 1. Here we are putting 1 square minus m plus 1 should be greater than 0. So it is 2 minus m greater than 0. So m minus 2 is less than 0. So m is less than 2. So m is from minus infinite to 2. This is the second condition which we have to write down. Now we are going for the third condition, that alpha plus beta by 2 should be less than 1. So what is alpha plus beta? It is m. So it is m upon 2 less than 1. It means m is less than 2. So this is the third condition. Now we are going to take the common solution for all the three, satisfying it. So it is minus 2, it is 2, and it is okay. It is minus infinite and it is infinite. So what one condition says, minus infinite to minus 2 close interval and 2 to infinity. Second one says minus infinity to minus 2, and third one says minus infinite to 2. So what we are finding is this is our common solution, dissatisfying. So answer is m is from minus infinite to minus 2. So this is the solution. This is the condition when both the roots are less than. So that's all in this video. Rest will discuss in the next video. Thank you.